Kinematics 17. Motion under gravity in 2 dimensions. S is gone, 2 dimensions. I put it 1 because today itself it won't be over. Or you can also say motion in a plane. Here, motion under gravity in 2 dimensions, you can say. Or you can say motion in a plane here also. Motion in a plane. And popularly, we call it projectile motion. Remember, even a body projected vertically up would be a projectile, to be more correct in terms of the English meaning. But generally, this kind of bodies projected like this are referred to as projectiles. Probably because these things are very useful, very practically useful in what ballistics, not ballistics exactly, like guns, war guns. You fire a shell out of it, it goes in that path and falls. People talk of range of that gun. There'll be even up to some 30 kilometers you can fire a shell, the range along the ground. So that is developed into a very, very serious science, the projectiles thing, because they're basically used in wars. Okay, so whether you call it motion under gravity in 2 dimensions, projectile motion, motion in a plane, it doesn't matter. So let us start that. You'll put a heading as usual, motion under gravity, but in 2D. Okay. And one more thing, of course, few assumptions let us make. I told you already, whenever you're projecting bodies over Earth, remember, you need to consider the curvature of the Earth, which we mostly ignore, because at a given small local place like that, Earth looks flat, isn't it? It's a horizontal like this. But this is definitely going to be important later under lesson called gravitation, where we think of projecting bodies with higher velocities. G will be towards center, like this I told you already. But in our case, we simply say it is like this we say. That means we think the gravitational field is uniform. So that small assumption we make. It's okay, because we're talking of small speeds. So when you're talking of small speeds, the distance it goes will be small only. So in that small distance, this curvature may not be that important. Are you following? Hello? No, my point is, if you take the curvature, direction of G keeps changing. This is a non-uniform field, we say. Hello? Because every time G will be towards center. When you throw a body like that, G won't be all the time in downward direction like that we showed, in a vertically downward direction. But since we're talking of small speeds where the bodies only go to a smaller distance, that assumption is okay, that we are taking it to be flat here and G to be constant. Okay, do you understand whatever I was trying to convey? We put like this, And anywhere G is in the y direction, we say like this. Do you follow?
Yes, sir.
Right. Now, in such case, we say we project a body like this with certain velocity, initial speed v0. Had there been no G downwards, the body would have gone straight. Do you agree? If I throw a body like that, if I throw a body this way with v0 initial speed, in the absence of gravity, it would go like that only. But gravity is there, or acceleration to gravity is there in kinematical terms, or force of gravity is there in dynamic terms. So it will be following some kind of a path like this and falls. Do you follow that? Why does it fall like that? No. Like that it falls. This will follow. Of course, we have not proved it yet, but it will follow a parabolic path. That's why we call it motion in 2 dimensions. Like we can analyze this whole thing in 2 dimensions. Like when a body is somewhere here, if I take this as my origin 0, 0, it had traveled some distance x and as well some distance in y direction, right? So this is the meaning of in 2D. Do you follow?
Yes, sir.
And like I told you also, G is once again supposed to be constant. Assume G is constant. So in 2D, and this motion is also in a plane of x and y. If I say this as x and this as y, motion is taking place in an xy plane, right? Hello. Motion is taking place in the xy plane. Remember, if there is a constant acceleration like this, it will happen like that only. We'll mathematically discuss it later. So we said parabolic path just like that. But in physics, every time, remember, what did I say? Yeah, we cannot simply say in words in physics. We need to put that in mathematical terms. But to get an idea, I'm talking all these things. Yeah, one more thing we need to think is we are not considering the air resistance. It's very important. Here, ignore air resistance. That means only force acting is what? Only force acting is mg. The weight of it or the gravitational force or whatever you say. Hello. Or is there any other force? If I ignore air there, is there any other force? Hello. You are throwing it, no? You apply a force. Won't that force be there acting on the body?
Yes, sir.
Huh? Okay. Tell me. No. You are applying a force for a while it is in your hand and giving it a velocity. You're no more in touch with the body, remember it. So if you're not in touch with it, you don't have a force acting on it because of you. What the body has is velocity, not force. Takshi. Do you follow?
Yes, sir.
When I throw a thing like that, don't say that I applied a force, that force is with the body, you think. No. The force is developed here. The force will develop between you and the body because of touch. There's a real interaction. So when this body leaves your hand, don't ever say that I applied a force, that force is following the body. You should never say. What you've done is, the body was in your hand. By applying a force for a small time, you just gave it a velocity. So once you give a velocity, the only force acting is what here? Gravity, gravitational force. Do you follow? Unlike in the previous, no, I'm taking a lot of time to make you understand this whole physics of it. What is there on the diagram is geometry and algebra. But remember, we are modeling one physical situation in these terms. Damodar, you're not coming regularly. I have to talk to your parents. Okay. What did I say? I don't know whether you understood by now. The whole physics is a mathematical modeling of nature. That too in 2 dimensions, mostly. The way we draw the pictures and all that, we try to give a 3D picture, 3D perspective, even if it is a 3-dimensional this thing. But ultimately, you show that on a paper, 2-dimensional, what you call plane you show. So that is what you mean by modeling. This modeling is there everywhere, believe me. I'm not talking about the what you call that modeling. What is that modeling like in the beauty industry? I'm not talking about that. Here, what is happening there physically in the nature, we are putting it in mathematical terms. Isn't it so? So here, there are few words used. I hope you understand the meaning of the words. The motion is only under gravitational force. That's why motion under gravity. Do you follow? Hello? Don't
Yes,
say it's
sir.
obvious. You just, somebody told, when I throw with the velocity, I have got the force acting on the body even later. No. Right? So once the body is just projected, you understand, the body is just left your hand. There's no force acted upon by you on the body there. Okay. So, and we, for our convenience sake, because if I take the air resistance, the path won't be so symmetric like this. Okay. So ignore air resistance, right? And the body, once given a velocity, is moving only under the action of a force called weight, or under an acceleration called g. So that's why motion under gravity. In 2D, this motion is easily analyzed in 2-dimensional plane. Do you follow? Hello?
Yes, sir.
So that is the meaning of all the statements I took. All right? And many other assumptions. G is constant. We simply don't bother about this curving of the earth here. We'll put it straight like this. And generally, you can call this as horizontal. This as vertical also. We ensure that vertical is along y, horizontal is along x. All right. So now we have to discuss the motion of this. I'll go to the next page. Have you all taken down what all I was talking? Whatever is written on the screen? Hello.
Yes, sir.
Yes, sir.
Now I'll redraw and keep doing things. Now put a nice parabola here, but first put a velocity here. So the path should be like this only, children. I'll take a little bigger one. Let me tell you what I was meaning to say. If velocity is like this, never make the body go like that. What's the mistake in that? Can somebody tell me the mistake?
Sir, it is showing that the ball is going at an angle more than with which we have thrown.
That is okay, but you already learned certain things. This velocity will be along the tangent to the path. Hello, Sriram?
Yes, sir.
So if you give velocity like this, it cannot go like that.
Yes, sir.
Huh? Do you follow?
Yes, sir.
You
Yes,
should
sir.
say that the velocity should be along the tangent to the path.
Yes, sir.
No, what you told is not bad. My point is that has to be modeled into a mathematical picture. That's the whole idea is that. Huh? So I'll
Yes,
put
sir.
parabola first to make it look nice. Hello.
Yes, sir.
This is x-axis. That's why. Now let me put my velocity. Which way?
Tangential to the path.
Tangential. Instantaneous velocity all the time along the tangent was the statement we made in kinematics. So this is my initial speed. How is it different from our old case? We simply project the body like that. This is why one dimension we told. Now it is two dimensions. Okay. And you're also given that this angle is theta. Right?
Yes, sir.
Let me say this is my x-axis, this is my y-axis. Huh? So say a body is projected with a speed v, speed v0 of course, making an angle theta with the horizontal. Not that theta I should take here only, I can as well take there, doesn't matter. Huh? Sure.
Yes, sir.
Now, what do you mean by discussing the motion? Discussing the motion is given the acceleration, for example, here acceleration is known as that is g all the time vertically acting down. So what is its velocity after some time? What is its position after some time? What is the path taken by it? Huh? This is what you mean by discussing motion. Hello? So what are the conditions given? What are the initial statements given? V0 is given, theta is given, and G is known. Huh? G is known to be acting
In the y direction.
yes, acting in negative y direction, right?
Yes, sir.
Right. Now we need to find out few things. First thing is this. The first point is velocity at a time t. How much is the velocity? Because I know v0, I know theta, but I don't know how this velocity changes later. So at time t, you think the body is here, for example. So once again, the velocity will be along the tangent, children. Anytime, again and again, I'm telling you, direction of velocity, instantaneous velocity, velocity time is along the tangent to the curve. Okay, hello. And that's also the direction of motion. Direction of acceleration is never the, never means sometimes it agrees with the direction of acceleration, but by definition, you can never say that the direction of acceleration is the direction of motion. Why? Because acceleration is change in velocity. So the acceleration will have a direction of change in velocity, not velocity itself. So this is v after some time. You may put bars also if you want. Okay. So once, and look, velocity at a time t I want. What we do in this kind of two-dimensional motion is a general statement I'll make here. The whole idea of what does it mean to say two dimensions, I'll tell you. How do you analyze motion in two dimensions? You are given v naught. So resolve initial velocity into what? X and y directions. And in x direction, no acceleration, isn't it?
Yes, sir.
And in y direction, there is acceleration. There is g. So apply equations of kinematics in both the directions separately. This is a technique. Okay. What I say? What did I say? Apply what? Equations of kinematics in X and Y separately to understand the motion. So that's what we're going to do now. Okay. Therefore, let us resolve this velocity into two parts. Tell me, this is my V0
Cos theta.
cos theta. You all know the adjacent component is cos. This is
Sin V0
V0
sin
sin theta. Okay. So resolve initial velocity into components. Now, look, V0 cos theta doesn't change. V0 cos theta part doesn't change. Why? There's no G in the direction, right? V0 sin theta keeps changing. Because of what? G. Do you agree? Hello.
Yes, sir.
So I want immediate feedback. So the final velocity also will resolve into parts. Because we need to deal with the motion separately. You may call it Vx. You may call it Vy. What will be this angle, children? Theta or something else? Something else, right? Hello. So Vx is V cos alpha. Vy is V sin alpha. What do you say? Hello. But V cos alpha will be how much? But V cos alpha will be simply equal to that is Vx will be simply V0 cos theta only. Do you follow? I want immediate feedback. I told you. You have to think. You can't simply, write equations and blind equations and then blind fixing doesn't work. What I was trying to tell you was, I told V0 cos theta part doesn't change. Do you understand the statement? Why it doesn't change? Because acceleration is only in y direction. This cannot change. It doesn't mean that the speed and angle don't change. Speed will change. This angle will change. Angle it makes with the horizontal. But this product will be equal to once again V0 cos theta. The theta changes. Array, isn't theta changing? It's becoming flatter as you go up, right? In fact,
Yes.
at this point, it is like this, isn't it?
0 degree.
So angle is decreasing, isn't it so? Hello, children. So
Yes,
do you
sir.
really understand this statement properly with meaning? There is some other velocity here, but its component is V cos alpha, which is nothing but V0 sin theta, right? So, but Vy, which is V sin alpha, which is equal to V0 sin theta minus GT. Do you agree? V equals U plus AT I applied, children. Only in the y direction there is G acting down. But in y direction, the initial speed is how much? V0 sine theta. So, but g is going to decrease it, right? V equals u plus at we applied. Here, what did you apply? V equals u plus at is applied in the y direction. Hello. Are you okay with that?
Yes, sir.
Now, I'll go to the next page. Therefore, V equals, after some time, which is root of Vx square plus Vy square. Isn't it so? Hello? This square plus this square is this. Huh? So what should I write? V0 cos theta whole square V0 cos theta whole square plus V0 sin theta minus GT whole square under root. All right. And tan alpha equals, even alpha you require, not only the magnitude, Vy by Vx. Hello. Tan alpha is this component by this component. So that is V0 sin theta minus GT by V0 cos theta. So therefore, at a time t, is that. If at all you want to understand it with an immediate numerical, you can say that. Say somebody projected a body with V0 equals some 40 meters per second and theta equals some 60 degrees initially. So what will be our V after some time? V0 cos theta. Tell me, 40 cos 60 whole square plus 40 sin 60 minus 10 into some time t. So at t equals say 1 second, how much is the velocity wanted? So gt into 1 whole square under root. Isn't it so? So 20 square plus 20 root 3 minus 10 whole square under root. This is 400 plus 20 root 3 minus 10. 20 into 1.732. How much is it? Hello.
Yes, sir.
Into, oh sorry, 3 and one more 0. So it is 34.6, right? Huh? Hello. So 34.6 minus 10 whole square under root. So this will be 400 plus how much is this? 34.6 minus 10?
24.6.
24.6. Can I make it 25 approximately? Huh? Hello.
Yes.
So 25 square will be what? 625. Right?
6.
So this is how much? All right. So how much is 1000 root 20,000 25 under root? Tell me. How much is that?
45.
Huh?
45.
How much?
45.
45. Oh, 40 into 4.
Oh, sorry, no.
How much, Suita? It will be some 30 something.
32.
32. Yeah.
Approximately 32.
Approximately 32. Huh? Right? And tan alpha will be how much? I want you to do the whole calculation because that's how you'll understand the whole thing. Tan alpha equals, we already have V0 sine theta minus GT. How much is that? V0 sine theta. V0 is 40 root 3 by 2 minus 10 into 1. We already know that. V0 cos theta. 40 into this. This is how much we got, 34.6. Huh? 34.110. How much is 25 nearly, right? Huh? We wrote it as 25 nearly, isn't it?
Yes.
Yes.
By 20. How much is this? 5 by 4. Okay. So you can look into tables, you'll get the angle. Can you tell me how much is tan alpha 5 by 4? You can use a calculator, scientific calculator, or you can see in the tables. Tan alpha 5 by 4 means how much is alpha? Hello, no one knows how to look at this one. Hello, children. Can somebody tell me? Five by 4 is how much? 1.25. Huh?
51 degrees.
51 degrees. Are you sure?
Yes, sir.
Did you see that?
Yes, sir.
Okay, alpha is 51 degrees. Now, why I want these angles, I'll tell you now. Look at this. The question is this. We throw a body with certain velocity called 40 and certain angle 60 here. It is going like that. After 1 second, what happened, you know? The speed became how much? Where is our speed thing? 32. Huh? Speed became 32. The angle became 51 degrees. So that's how the speed and direction keep changing. Hello? Do you follow?
Yes, sir.
We took after 1 second, what happens? All right. So can I continue? I've written down things for you. Generally, I don't do so much. Hello, children. So the first stage was what? To find out the velocity after some time. Why am I starting with velocity? Can you tell me? Because I was given initial velocity. Do you follow? And I've understood that, yes, I can analyze this motion in 2 dimensions. Because when I looked at a body at some point in the parabola, it has covered some distance in x direction, some distance in y direction. So it will be convenient for me to discuss the motion in 2 dimensions because only in y direction the speed should change, not in the x direction. So I'm applying my equations here separately, here separately. Is that all right? Hello?
Yes, sir.
Now, after velocity, x and y position we wanted. I'll keep drawing pictures again and again. You also do that because I really want you to understand that discussing motion means all these things. Now I've taken this once again, all over again. So V0, we said at this point, what was the direction of velocity? Along the tangent. Hello. So by the time it went there, it covered one distance in y direction, the other distance in x. This was already told to be theta. Here you say position of the particle. Hello. What are our components of velocities, children? This is V0 cos theta. This is V0 tan theta. Huh? Isn't it? You're not saying when I said V0 tan theta, you're not even objecting that it's not tan theta. Huh? V0 sin theta. Now, remember, if I apply S equals ut plus half at square in both the directions, look, x equals, what is the initial speed? V0 cos theta into time plus half. A is how much in this direction? 0. So x will be simply V0 cos theta into time. Do you follow? And y will be V0 sin theta into t minus half g t square. Do you agree? Hello. This is the second
Yes,
thing. First one was velocity. The first thing we did was what? Velocity at a time t. Now, second thing is position, that is x comma y at p. That's what I mean by position. So x is this, y is this. Hello? 3. Path of the particle. Remember, path is always the relation between the position coordinate. Position coordinates are what? X, Y, Z. Right? Path is always the relation connecting what? X, Y, and Z. So I should eliminate t from this x and y to connect x and y, isn't it? Therefore, let us eliminate t from x and y. Okay. 3, I'll continue here. This one. Look, I'll take this y expression here. Y equals, what do I get? V0 sin theta. In the place of t, I will put x by V0 cos theta because I want t to go. So t equals x by V0 cos theta, children. Okay. V0 sin theta into t. T equals x by V0 cos theta, I put here. Minus half g. G is g, nothing, that's a constant. T square. X square by V0 square cos square theta. So t is eliminated. So this will become what? Y equals x tan theta. Am I correct? V0 cancels. Cos theta by sin theta by cos theta is tan theta. So x tan theta minus half g x square by V0 square cos square theta you can leave, or V0 square you can write, and top secant square theta you can write. That is not a big deal. V0 cos square theta. This in what form? Y equals ax minus bx square. This is a Parabolic equation. So that's how you find out the path. Hello, children. And in fact, if you want to improve, the first thing you should do is after the class is over for half an hour or so, you should sit and study it for a while, 5 to 10 minutes, because you are writing anyway. Put that away and take some rough sheets and keep on doing it, thinking in your mind. You just see how you can write all these things, derive all these things. Okay. So tell me if you finished. I'll continue to the next slide. Children,
Yes, sir.
there's the equation of a parabola. Try to understand. Y equals ax minus bx square is a parabolic equation of this type. A is tan theta, B is that remaining thing, half g by v0 cos square theta is b. Do you follow that? Hello?
Yes, sir.
Yes, sir.
So this A is tan theta. This B is all this. Other than x squared, all this is b. So we studied velocity after time t. We studied position coordinate x and y after time t. And we found the path. All right. I'll here pause for a while before going to the other heading. I'll show everything in vector form now, IJK form. Can I go to the next page? Come on, great persons, tell me.
Yes, sir.
Now I'll draw the picture again. So I'm drawing the same thing again and again. This is V0 and the path must be like that. Okay, short one. This has come now, no problem. Now, this was theta. So this is V0 cos theta. This is V0 sin theta. Now that was V somewhere. I'll put it in this different color again. This is V there. It's also supposed to have a V x component and a y component. Now first one we wrote was function velocity, isn't it? So V bar equals, I should write like this. This component is how much basically? V0 cos theta, isn't it? Hello, it's already there. It is V cos alpha, but that's equal to V0 cos theta. Do you remember? Hello.
Yes,
Oh, feedback. Nobody says anything. V0 cos theta I cap plus. Now what will be this component? V0 sin theta minus GT J cap. Is it okay?
yes.
Hello.
Yes, sir.
And second position. This is R bar, children. This is y, this is x. So R bar equals, what should I write? Go back and see. V0 cos theta into T I cap plus V0 sin theta into T minus half GT square J cap. Which one is R? Do you know? This one. Not that black path. This is the point joining directly to the origin to that point. That's what R bar. So in vector form. Of course, path won't be shown in vector form. Path was what? As usual. Can you tell me? Y equals x tan theta minus half g. Tell me. By V naught square cos square theta into x square. This is separate, of course, from that. But in vector form, we could write like this. Again, I'll write from, we are still continuing that techniques. Hello. Amar,
Yes, sir.
have you got any question?
No, sir.
Okay. Next, I would like to find the time of ascent, as people call it. What is it? I'll show you. Can I go to the next slide? I'll go. Look. I'm drawing the same picture again and again. So this is V0, right? And this is the path. All right. Not time of ascent first. I would like to find, I just use the same figure for many things. I'll save my space here. Time of flight. What is time of flight? You know, the time for the body to come back to this point. Okay. The body, now it won't come back to the thrower, isn't it? Hello.
Yes.
You're throwing it from ground, it's coming back to this point where the motion is supposedly over. All right. So what was the initial velocity in the x direction? V0
Cos
cos
theta.
theta. What was the initial velocity in y direction? V0 sine theta. Though the body went increasing heights, it went to a maximum height there, but came back again and fell here, isn't it? Huh? In y direction, the displacement is 0, isn't it? Huh? After time of flight, displacement in y direction is 0. This idea I'll apply many times in different problems. Isn't it so? There's no displacement in y direction. Hello.
Yes, sir.
So apply C equals UT plus half AD square. So 0 equals, what is U in y direction? I should take only y component, not this one, neither this one. So how much is that? V0 sine theta. Let me say time of flight is t. Minus half gt square, isn't it so? Hello. So it implies t equals, if I take it that side, 2 goes, 1 t cancels, 2 V0 sine theta by g. After so much time, it falls back here. And remember, this is a special case of theta b equals 90. When I throw a body up with V0, we said V0 by g, it goes up, V0 by g, it comes back. That is also V0 by g. But theta was there, how much? 90. So sine 90 you put, it will go back to that. Do you follow?
Yes, sir.
All right. Now, time of ascent. I forgot the numbers. You put the numbers. 1, 2, 3. The derivation parts. I've given numbers, but now I forgot what I wrote in the previous slide. Time of ascent means time it takes to go to the maximum height. After that, it comes back, right? So at the maximum height, what happens, children? The velocity will be simply V0 cos theta. Don't say velocity becomes 0 here. Why? This v0 cos theta component is not acted upon by g. So it will remain as it is all the time. Only y velocity becomes 0 here because of gravity or g, because of g. Do you follow?
Yes, sir.
And remember, nowhere in the path the velocity becomes 0 here. This is the minimum velocity during the motion. All right. Huh? Do you follow what all I speak?
Yes, sir.
So to find out this time from here to there, for time of ascent, use v equals u plus at. So that becomes vy equals uy minus gt, right? Vy is 0. Uy is how much? v0 sine theta minus g into time of ascent ta. So time of ascent equals v0 sine theta by g. Therefore, time of descent td is time of flight minus time of ascent, which is also v0 sine theta by g. This is what? Time of descent, you can say. So, children, I hope you followed. It takes v0 sine theta by t to go there. I'll use the highlighter or laser pointer, where is it? Yeah. So from here to here, it takes v0 sine theta by g. From there to here, it takes v0 sine theta by g more. So the total time is 2v0 sine theta by g, and time of ascent and time of descent are equal. Hello.
Yes, sir.
Can I continue? One fellow already left. This kind of joining late and going early is a very, very bad habit, because there's no control on you. You do like that is disservice to yourself. Okay, shall I change the screen? One more fellow went out. It's not over. I did not say goodbye, right? Why are you people leaving? Just see tomorrow. Right. Now I'll change my screen. Next thing is, I would like to find out what vertical height it reached, maximum vertical height. It has come not properly. There's a symmetric parabola. Try to understand. Symmetric about this point. So this is what we call H max. Okay. So the heading is what? Maximum vertical height. So at this point, what velocity was 0? V in y direction was 0. This was our total V. This is our V0 cos theta. This is our V0 sine theta. So at this point, this velocity is there, but this was 0. So apply v square minus u square equals 2as. So 0 square minus u square v0 sine theta whole square 2 into minus g into h max. So h max is v0 square sine square theta by 2g, which was v0 square by 2g when it was projected vertically up. Compare with this. Theta if 90, it will go back to that formula. Okay.
Yes, sir.
After that, the horizontal range. This is called the horizontal range. The maximum distance covered in x direction. That is the horizontal range where it falls. For the war guns, this is the range. This is even, it can go up to 30 kilometers. Here you put a gun and fire the shell out of it. It goes like that, hits the target here. Huh? Hello. Now, look, we have from x equals v0 cos theta into t in the x direction. Huh? Or in x equals v0 cos theta into t. There's no half gt terms, half gt square term here. X is general distance we calculated, right? v0 cos theta into t. In x equals v0 cos theta into t, if t equals t, time of flight, x becomes r. Isn't it so? Huh?
Yes, sir.
So it implies r equals v0 cos theta into time of flight is 2v0 sine theta by g. So v0 square 2 sine theta cos theta by g, which is v0 square sine 2 theta by g. So this is something, when the elementary, the bare essentials for discussing this type of problems in future. Okay. So just go back and see how many things we learned. You can give numbers. Velocity is a function of time. X is a function of time and y is a function of time and path. Then time of flight, time of ascent, time of descent, greatest vertical height, and then the horizontal range. So we discussed it almost threadbare, like every possible idea we discuss it there. And this information has to be kept in mind. You should be able to use formulas for this kind of things, because these things become small parts in a bigger question, children, later. So no one can just go back and derive all this and do that. We should be able to immediately put the equations. But remember, all this was done by putting angle theta here. Suppose somebody puts angle theta there, sine becomes cos there, because sine 90 minus theta you get. So causes you get. So remember this theta, this v0, if you know, all the other quantities will be coming in terms of that v0 and theta. Of course, g will come anyway, because that is the constant. Is it all right?
Yes, sir.
So Vignesh, actually, I'm not seeing you applying things. So my point is this: you need to, I mean, without mother or father telling you, on your own, if you just repeat these things, actually in my class, if you can repeat what happened in the class, and you can repeat the problems you've done, you will overall improve. Not that like when people say I'm not getting marks in exams, I just don't even bother, because you don't get if you don't know. That means you are trying to study it in a bad way. But I'll tell you, it is not having some higher knowledge, I mean IQ or whatever. Whether you have a higher maturity, like for example, you have taken up a job. I want to finish it. If X does it in first attempt, I'll do it in second attempt. If not second, I'll do it in 10 attempts. That is very important in life. IQ is not, it's already there. The genes have already decided that, so I can't do much about it. But I mean, most likely. But what you can do for a particular purpose at a particular point of time in your life, you need to really go after a particular job you've taken up. That's very important. Go after it in a big way. So whether it is X, which is who is supposed to be good now, and Y, who is supposed to be not good, will become equal after some time. It's very simple. You need to work double hard. You ask any great achievers who were not very great in the beginning, they would tell you that I'm not that great, but I work double hard, people say. Like women keep saying, those who go to the top positions in the industry, they become chairpersons of the banks, they become CEOs of the companies. You ask them, they will tell you, yes, we had to work double hard, they say. Most of them will say that. So my expectation from you people is this. I can tell you, I can't make you do. I want you to just, I was just going in a very smooth, slow way, right? So you just take rough sheets, but study it for a while, throw it out, and then keep doing this continuously. If you don't improve in your application tomorrow, when I show some examples, some from this, you ask me. Vignesh Ramaswamy. Do you
Yes,
follow?
sir. Yes, sir.
Do that. I'll ask you tomorrow before starting the class. I may ask you to open a window and show your rough work. All right.
Okay, sir.
Thank you so much. I'll be ending the show.
Thank you, sir.
Thank you, sir.
Thank you, children.